Figure 2 shows a sketch of part of the curve C with the equation y equals 2 ln 2x plus 5 minus 3x over 2, where x is greater than minus 2.5. The point P has got x coordinate minus 2 and lies on the curve. Part A. Find the equation of the normal to the curve at P. Write in your answer in the form ax plus by equals c. So, normal, I'm going to first differentiate my function to get the gradient function. I can then know what the gradient of the tangent is at point P. I can then do negative reciprocal because the normal is perpendicular to that. So let's differentiate our function. So we know that when we differentiate a logarithm, we get 1 over the function. So 2 lots of the logarithm. So I've got 2 lots of 1 over 2x plus 5. But by the chain rule, I also need to multiply by the derivative of the inside function, which is 2. So I need to multiply this by 2. We also need to differentiate the minus 3x over 2, which is minus 3 over 2. So simplifying that, we get 4 over 2x plus 5 minus 3 over 2. At point P, so when x equals minus 2, if I substitute that in here, so 4 over 2 times minus 2 plus 5, so that gives 5 over 2. Therefore, the gradient of the normal will be the negative reciprocal of that, so minus 2/5. I can now say y equals minus 2/5 x plus c. I need to know a coordinate to substitute in here. I know the x coordinate is minus 2, but I don't know the y coordinate yet, but that's fine because I can substitute minus 2 into the original function to work out what the y coordinate is going to be. If I substitute minus 2 into this original function, I find that y is 3. So substituting 3 here and minus 2 here, I get 3 equals 4 over 5 plus c. So c is 11 over 5. And the equation of my normal is minus 2/5 x plus 11 over 5. To write it in the desired form, I'm going to multiply both sides by 5 and then add the 2x to the other side. So we get 2x plus 5y is equal to 11. And that's my answer for part A. We are then told that the normal to the curve at point P cuts the curve again at point Q, as we can see in the diagram. Show the x-coordinate of point Q is a solution of that equation. So point Q is where the two curves intersect, or the curve and the line intersect, so it's simultaneous equations. So I am going to substitute I'm doing simultaneous equations, so I'm going to substitute this y function here in instead of the y here. So I'll get 2x plus 5 lots of the 2 ln 2x plus 5 minus 3x over 2 equals 11. Expanding these brackets out, 5 lots of the 2 ln, so that's going to be 10 ln 2x plus 5. Now I've got the 5 times 3x over 2 is 15x over 2. Next collecting up these, let's times everything through by 2 actually to get rid of that fraction. So 4x plus 20 ln 2x plus 5 minus 15x is equal to 22. Collect the x terms together, that's going to be minus 11x. Move the 11x to the, add that to both sides. And then if I move the 22 to the left hand side, and then divide both sides by 11, so I'll get the 20 over 11, the 22 over the 11 will become 2. And this was what we needed to show for part B. We are then told that the iterative formula given there can be used to find an approximation for the x-coordinate of Q. Part C, taking x1 is equal to 2. Find the values of x2 and x3, giving each answer to 4 decimal places. So if I first just substitute 2 in here, so I'll get 20, typing into my calculator, 20 over 11 times ln of 2 times 2 plus 5, close the bracket, minus 2, and to 4 decimal places I get 1.9950. And then if I take my answer and substitute that in instead of the x, and do that calculation again, I get 1.9929. So that is my x3. And we're done.